Hello everyone. Our topic today is three-phase full wave uncontrolled rectifier. When we say full wave means we will have we will be using 6 diodes instead of 3. Last time in three-phase half wave we used 3 diodes. So the positive only go through, the negative no. Now we will open path for the positive, and we will open path also for the negative. Okay? So instead of 3 pulses per cycle, we will have 6 pulses per cycle. Let's see. Okay. Okay. So now this is. This is my bridge right here. This is, we call it bridge. Okay. And we have 6 diodes. So let's follow the phases, the currents. So we will have, as I told you before, 3 phases. If this is A and this is B and this is C, the phase shift between phases is 120 degrees, and also between phase B and C is 120 degrees, and 120 degrees between C and A. I want to make a note, guys. If you see a V source like this, and you see Vmax equals Vmax times sine omega t, the value that you see here, guys, is Vmax. Let's say if it's 120, then it's Vmax in this case. If this is 120, so Vmax equals 120. You don't have to do the calculation, which is times square root of 2, all that. No. If it's given like this, if the equation is given like this, V source equals 100 sine omega t, then V max equals 100. Okay? This is a note just for, for the whole term. Just know this. Okay, let's follow here. Let's look at A. This one will start from 0, A, as we know. Okay, which is this one here, the blue. Okay, and of course, this line right here, it will be fully charged. This line will be fully charged. So this polarity will be flipped. This will be an open circuit. So the current will go up. So this diode right here, we will call it diode number 1, because we name the diodes according to the sequence. Then the current will go, it cannot go through this diode. Same thing cannot go through this diode. So it will come through the load, and this is positive and negative. If we look at V out, and use another color, which is positive here, and this is a negative, and this is V out DC across the load. So we came to the load from the same direction, from positive. Okay, then as we said, this line will be fully charged, so this one here will be open circuit, so no current will go through. The current will go through either this or this. Okay. So which one it will go through? It goes from A, and then what? It cannot go to B, guys, because B will start now, will start after this, so they go by sequence. So if it starts from A, it has to close by C, because now A will start, they go by sequence. A, then B, then C. So this one here is diode number 2 by sequence. So now I close the circuit. It's not going to be, because B will start now. So if you start with A, then it closes with C. If you start with B, it's not closing with C, it's closing with A. It skips 1. Okay? So that's A, which is this. I can use this one here as red if you want to, guys. To follow that. Okay, so this one here is A. This is my peak here. Say again, guys. 1, 2, 3 peak, 1, 2, 3, 0, 1, 2, 3 peak, 1, 2, 3, 0. This is A. By the way, guys, I am drawing V source. V source. Okay? This is V source. Then, I'm going to use black. So B, after 120 degrees, I will start B. So I will start this one here. Okay? So now I am connecting here, guys. Okay? This line here will be fully charged. So this one here will be positive and negative. So this the polarity will be flipped. So this will be open circuit. So when the current comes, it cannot go through this one right here. So the current will go through this, and we call this one diode number 3. Okay? And then it will go here. It cannot go through this diode, as we know from before. It will go to the load from the same direction, which is positive. Okay? And that's rectifying. So we are directing the whole current to go to the load from the same direction, which is positive. Then it will go out. As we said, this one here, this polarity, because this is fully charged, it will be an open circuit. So it will go either to this one, to this diode, or to this. And as we said, if we are in B, we cannot close with C. Because C will start now, after this. So we have to close with A. And this one here is diode number 4. Okay, so and then it closes right here. Okay, so I can go at this is 90 degrees here, guys. Okay, and this is 60 degrees, and this is 30 degrees, and this is 120, and that's where we will start. And this is 150 here, and this is 180, and this is 210, and this is 240, this is 270, and this is 300, 330, and this is 360. We are interested, guys, only in one cycle, which is 360. Okay, 2 pi. This is my T time from here up to here. Okay, so if I ask you to make T 1 cycle, okay. If I ask you to make T 2 cycle, then you make it 2 cycle. So here T is 1 cycle, which is the time. Okay, so we start. If this phase, which is A, starts at 0, then phase B will start at 120 here. So we count 3, 1, 2, 3, and that's my peak here. Okay, and then 1, 2, 3, that's my 0. And then 1, 2, 3, that's my negative peak, but I'm not interested on that. I am interested only in 1 second. Then I'll go back and finish. 1, 2, 3, that's my peak. Then 1, 2, 3, that's my 0. And I am interested only on this. This is B here. Okay, what's left is C. C starts at 240. Okay. So this is C here, so I will start from here. And this one here, so as we said, this line will be fully charged, so this will be an open circuit because the polarity will be flipped. And now this one here, this diode is diode number 5. And now the current is going here and coming here. So you can see, guys, that this one, this current, and this current and this current come into the load from the same direction. Okay, and then we will go out. As we said, this will be an open circuit. And if we start with C, we have to skip A. We'll go to B, because now A will start after that in sequence. So this one, this diode right here, this power diode is diode number 6. Okay, and we close here. We start with C, we skip A, and we will go to B. Okay, so that's here. Okay, that's how it will work. And it will start at 240. So 1, 2, 3, that's my peak. And then 1, 2, 3, that's my 0. I'm not interested in this, I am interested on that. I forgot this. Finish the C part, the C phase. 1, 2, 3, 1, 2, 3, that's my peak here. 1, 2, 3, that's my 0. 1, 2, 3, that's my peak here. I'm not interested on this. Okay, that's C. This is my V source, guys. This is V source. As we know from before, this is V source. How to get the V out, since we have 6 diodes. Last time when we did the 3-phase half wave, we erased all this. This is the negative because we said that the positive signal only passes through the diode because we only have 3 diodes. So the negative is gone, nothing. And we took the highest point. So our output for V out DC for 3-phase half wave was this. I assume you guys still remember that from last lecture. But now, no. Now we will have the positive and the negative. So we're going to have the positive and the negative. So how to draw V out DC? Of course, the more diodes we have, the bigger peak we will have. So last time, this is our peak. In 3-phase half wave, this is our peak here. See here? It's not the wave is not touching the x-axis, not touching the 0. Okay, the peak is obvious. This is my V out DC for 3-phase half wave, which is 3 diodes. Now, if I use 6 diodes, my output will be here. So my V out DC, I'm going to use the black. My V out DC will be around right here, guys. Okay. It will be right here approximately. Okay, V out DC. But how to draw it? Let me show you a technique, guys. You can draw it from the source immediately, or from the bridge itself. We can draw the bridge. We can draw all diodes. We will do this, and then we will do it right there. Okay, let's see here. You look at the V source from the left, and you start with the first peak, which is negative or positive, all. So this is my first peak, so you make a line right here. Make a line. All the way here. Okay? The next peak is this, the red one, which is A. Make a line. Okay? Next is the green, which is C. Make a line. Make a line here. Next is B, which is black. Make a line. Next, again, A, but negative, peak, same thing, so make a line. Next is C, and it's a positive peak. Make a line right here. Okay? And now you can draw the 6 output pulses easy. So you come here. Okay, you will have this part of B and this part of A will make 1 pulse. This part of B, phase B, and this part of phase A will make 1 pulse, which is this. Okay? Then, this part of C, of phase C, and this part of phase A will make another pulse. Then, this part of C and this part of B will make another pulse. Same thing, this part of A, negative, and this part of B, positive, will make this pulse. This part of negative A, phase, and this part of C, positive, will make this pulse. Okay? And this part will make part of the pulse, which is half. Yep. And this part will make this. So I have 1 pulse, 2, 3, 4, 5, 6. 6 pulses per side. And that's my peak. You will see that even in lab, that when you do your lab, I think I already explained it for you in lab, for some of you guys, the peak, you're not going to see it in the oscilloscope. So you need to assume that instead of 0 is your x-axis, we will assume that -1 is your x-axis. And you will count, you will assume that -1 is 0. And you will see that the peak is around like 4 boxes, 4.5, 5, something like that. Okay, so this is now V out DC, guys. This one here is V out DC. Okay, what will be the current? I out DC. I out DC. It depends if the load is resistive load, and if the load is inductive. If the load is resistive, guys, we will have approximately the same, but it will be lower, guys. It will be right here. So you will see it like this. Okay. Then the current will be look like this. Okay. This one here with R load. Okay. If we have RL, this will be smoother. Okay? It will be smoother. So I'm going to use the green, guys. So it will be like this. So this one here with RL load. Okay, smoother. This one here, I out DC also. I out DC, but with R load. That's what you will see, guys. We are here in your textbook. Okay, on page 144, guys. And that's what we have drawn. The source, and then we draw the output, which is V out DC from the source. We will draw the bridge right here, guys, on the same page. Okay. So if we come and draw the bridge, also we have to use some technique right here. So let's take this with me right here. Okay, let's see here. This is the x-axis, so I'm going to make points in the x-axis with the same distance. Okay, I'll make points with the same distance, guys. And then I will make 2 lines up and 2 lines down, dots. But I will shift the dots. So here, I will make a line right here. Same distance, but shifted. Okay? Same distance, but shifted. Shifted 50%. Then I'm going to do another one, another line with the same. I mean, the only shifted ones will be in the x-axis. The rest will be this in the same place. Okay, will be in the same place. I'm going to go down, do the same. Here, 2 lines. Okay. I'll do 2 lines. So you can see that I have 1, 2, 3, 4, 5 lines. So you need 5 lines to draw the bridge. The x-axis line will be shifted. Okay? Will be shifted. The rest will be the same. See here? Those are parallel to those. Okay? So, better. Okay. Now what you need to do to draw the bridge, you need to go diagonal. Okay? So I'm going to draw a diagonal line to connect those 3 dots. So here. Okay? Diagonal lines. Okay? See here, diagonal lines to connect the 3 dots. leave those. Leave the last one on the top, so just draw those. Okay? Then draw another diagonal which make X. Make the letter X. Okay? So here. So I'm gonna X all. Doing the same but opposite, diagonal. Okay? Okay, now, you want to start from here, guys? So if you want to start from here, you go. You'll make your peak next point. So you start from here. Your peak will be next point. So you will skip this. You will start and you will skip this one right here. So my peak will be next point. So I'm gonna go like this. And then I will skip, I will go to next one and connect with next one. Then here, I'm gonna start here. My next point is my peak. Okay? And then go to next. Same thing. Go to next. Same thing, guys. Go to next. Okay. Then I can finish this one here. Okay, can go like this. Wow. Let me start from here, guys. This one here, if you look at, remember last in half wave, three-phase half wave, we said that we will take the highest point. We're gonna do the same. When we draw this, I told you that my output will be the highest point. Okay? Now you guys see here? That's why we draw the peak right here. We said it's high peak. See the peak here? From this is the x-axis, and that's my peak. So you're gonna look at the highest points from the top. So one cycle. So your output will be this 1, 2, 3, 4, 5, 6 pulses. Okay. So this is the same right here. I mean, I can shift. I can make this one right here. Right here. And it's exactly the same as this. Okay, and then we know that this one here. Okay, so this one. This I want to see where is my 360 degrees. So we know that this one is 90 degrees. Okay, let's follow where any cycle. Okay, let's follow any cycle. Oh yeah, I have to finish this one. This part right here. Sorry guys. Yeah, I'm saying there is something missing. I have to finish this. So we're gonna do the same. So we're gonna come here to the peak. Okay. And then same thing right here. I'm gonna do the same thing right here. Okay. Gonna do the same in the negative part because this is the full wave. I'm gonna do the same, guys. Okay. And then I can finish from the negative here. And can come here. And my peak, this one here is this. So this is a bridge, and now we can follow any cycle. So in the textbook, this is what we have here. It's the same. And that's AB. look at this. So this is A, B, A, C. So the first one is A, B. This is AB right here. Yeah, I want you guys to pay attention to this, how we're gonna have the numbers. So we will have A repeated 2 times. So A will be connected with B, and then A will be connected with C. Okay, so A, B. The next one is A, C. Now A is finished. Okay? Now B, C. Now which one will be repeated? C will be repeated. And B, actually B will be repeated 2 times. B, B here. Okay? So A, B, B, and then C, C. Okay? A, B, B, C, C. Okay? That's what you will see. I mean, if you look at it right there. Okay? And then, okay, A, B, A, C. Now C will be repeated. B, C. And then B, A. Okay? And A will be repeated. C, A. And then C, B. Okay? C, B. What will be next? AB, which is this. A, B. Means that this is the same one right here. If I follow this, it should be that one. Let me see here. I'm going to follow it. I'm going to follow this. Yes, it's this. Okay? So that's AB. Okay? So that's one cycle. You can follow this here. And then if you want to look at it from 0, this one right here, which is AC, AC, yes, it will be AC then. Because AB, then AC. Next is AC. That's AC. This one. But one cycle from here to here. I want to know that it's repeat. Okay, let's look at look at the diodes. Which diodes are here? Which diodes are here? And which diode on BC? Which diodes on BA? And so on. So we will compare the grid to our circuit and see the results. Okay, so we look at A, phase A. It's connected with 2 diodes. In the positive, diode 1, and in the negative diode 4. That's A. Okay, that's A. So we come here. We can do it there or we can do it here. It's the same. Let's see here. A, this one A, this is A. So in the positive, we said it's connected with diode 1. So this is 1, and this is 1. And in the negative, it's connected with diode 4. This line right here, this line right here, this line right here. See here? Diode 1, positive, diode 4, negative. So this is 1 and this is 4. This is 4. Let's look at phase B. Phase B. So here, phase B. Okay. In the positive, diode 3, positive. And diode 6, negative. Okay. So diode, that's phase B. So B in the positive is diode 3. So this is 3, 3. And in the negative, diode 6. So this is 6. In the negative, the pulse. Okay. This one here is diode 3, diode 3. Let's look at C. See? So this is my phase, which is C here. And the positive phase, or the diode in the positive, is diode 4, so diode 5, positive. And diode 2, negative. Diode 2, negative. So I will look at C. The negative is diode 2, so this is 2, 2. And the positive is 5, oh, this is 5. Okay? So I can say that the diodes are right here is diode 6 and 1. So this is 6 and 1. 6, which are active 6 and 1. Diode 6 and diode 1. And then here, diode 1 and 2. 1 and 2. They have to be in sequence. Then 2 and 3. 2 and 3. Then 3 and 4. 3 and 4. Then 4 and 5. 4 and 5. Then 5, which is this, still 5. And 6. We start from 6 here because this one, the previous one, is 6. So 6 2 times here. It works here and here. Going down, going up, same thing. 1, down, up, and so on. So now we know the diodes. Same thing right here. It can be 6, 6, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and that's my 360 degrees right here. 360 degrees. This is, here I can say that this one here now is V out DC, which is this. The highest point. Those are the highest points. So if you want to draw the V out DC using the bridge, you need to highlight the highest points. This is my highest points now. And those you're going to see them. You will not see all this and the oscilloscope. All you will see is the highest points, which is the V out DC. Same as this. Okay? So you can draw the V out DC using the V source and then, make a line through the peaks, or you can draw the bridge and then you can find V out DC. The current will be the same here, same as this. Okay, if we have R load, or if we have RL, which is inductive and resistive. Okay, and we know that the equation for V out DC equals 3 V max line to line over pi. Okay? We derive this from the previous one, which is the 3 times square root of 3 V max line to neutral divided by 2 pi. It's 6. It should be 6 diodes. Should be 6 diodes. And here 2 pi. So we just cancel the 2 with the 6 and we get 3. And of course the connection here is line to line, no neutral connected right here. That's why we have this equation. And you can see the equations in your notes. And I think I told you before that okay, so those are the equations, guys, in your notes on page 34. Okay, everything will be the same except that this will change, which is the V out DC. It's equals to 3 V max line to line divided by pi, and also the ripple frequency. Now we will have 6 times 60 because we will have 6 pulses, so 6 times 60, and okay, if you look in page 144, C, that will show you the current for each diode. So that's the total current, and it will show you, for example, I diode 1. Okay, it will show you I diode 1. Okay. So you can look at this. This will be, if you want to draw I diode 1, everything will be 0 right here, and you will see this only, and then 0. That's I diode 1. If you want to draw I diode 2, it will be shifted, so you're going to draw this. Okay. So this one, it will be, for example, 0, and you will see this. You will see the output right here for I diode 2, and then that's 0, and so on. Okay, you can see it. You can see it in page 144, part C, right here. In the I source, do we have positive and negative? Yes, because when we have the bridge, it means that we open path for the negative. When we have bridge, which is full wave, in single phase or three phase, it means we open a path for the negative. So in the I source, we will have positive and negative. Okay. This is the equation, which is the same one on page 146. You can also replace this equation by B out DC equals 0.955 Vmax line to line. Because if you divide 3 divided by pi, you know that pi is 3.14, you will get this. So this is the same equation. Okay? If you have Vmax line to line, you just multiply it by 0.955, and that's what you will get. In page 147, guys, we have the same diagram compared to the one on page 144. The one on page 144, part C, is this. Here, you can see it. This one here is the same, but we have straight DC. And I told you before, if you want a straight DC, you will make the inductance huge or infinity. Okay? So when you filter the output current, and to filter the output current, you need huge inductance. And if you want to filter the output voltage, you need a huge capacitance. So here we have high inductance as a load, and that's what we get straight. So to get straight DC current, you need huge inductance. In your lab, guys, that's what you will connect. This is the circuit. So it will be the same circuit as the half wave, but this line right here, instead of making it connected to the neutral, you will remove it from the neutral and you will connect it to the line, which is now diode 4 and diode 5 and diode 6 will be connected. So we will have the 6 diodes connected instead of 3. Because if this line is not connected here, only 3 diodes will be connected if we connect it to the neutral. But we will remove it from the neutral. We will connect it here to those diodes. And you can notice now that they ask you to connect two resistive loads in series, where each resistive load is 150. So 150 plus 150 is 300. You can use 300 immediately from one box, but the output voltage will be huge. The output voltage, guys, will be huge. You will notice that the output voltage is like between 250 and 300, but it's 250 mainly, or most of the time it's 250. And the rated value for each box, resistive box, is 120. So if we use it for a long time, the resistive box can be damaged. So we will use 2 in series. So 120 plus 120, it will be 240, so it can handle our voltage. Okay? And you're gonna do the same here. You're gonna make a line and compare. You will compare the 6 pulses rectifier and the 3-phase to the 3-phase half wave. And here,
there's some questions. I want you in those questions to pay attention that this value is VRMS, which is the 220 in page 27, question 2 and question 3. 220 VRMS and this is 240 VRMS. We're going to do this in lab, but just if you want to do the work in advance. Okay. We have another topic, which is the multiphase. We have multiphase, okay? So we can have, this is in page 25. Multiphase means we can use 4 diodes, 6 diodes, 7 diodes, 8 diodes, 10 diodes. But this one has to be, we have to connect with the neutral, okay? So if you want to connect this, it will be like this here. So if I want to connect 4 diodes, I will have, this is a diode here, and this will be another diode right here, and this will be a 3rd diode right here, and this will be a 4th diode right here, and I will have the source, okay, and then I will have my load, and I will have neutral. This is called multiphase. This is called multiphase. And I can use 5. If I want to use 5, same thing, I will add this here. Okay? This is 5 diodes. And how to draw those diodes, guys? You have to know where's your alpha. You have to know where's your alpha, which is the firing angle. For example, now, guys, this is one of the points that it's good for you to know that alpha in three phase. This is my alpha right here. This is my alpha right here. This is my output here. Okay, this is my output, and this is my alpha. So when I have 3 phase, 3 diodes, my alpha equals 30 degrees. I mean that my first pulse, full pulse, starts at 30. Okay, so that's my alpha. That's my alpha. This is my alpha 1. Because I know that this is my alpha 1, and this is my beta 1. And at the same time, this is alpha 2, and this is beta 2, and this is alpha 3, and that's beta 3, okay? I wrote this last time. So what will happen now, I mean, just to let you know that this will shift. You need, I mean, if you want to get exactly the exact drawing, you need to shift this one. What I mean by shift. First, you need to calculate where's your alpha. Let's say let's calculate the alpha for the 6 diodes. We know that conduction. We know that conduction angle. Let me just show you here. Okay. We know that the conduction angle equals 3 phase 360 divided by number of pulses. Okay? We know that conduction angle equals 360 divided by number of pulses. Number of pulses. Let's say here we have 3. Okay?
1, 2, 3. So conduction angle is 120. So I know the conduction angle, okay, and I know the alpha. Okay, so here I know the conduction angle, which is 120, and I know the alpha is, so this will be my reference, guys. This will be my reference to find the alpha now. Okay, so I have the conduction angle, which is 120, and I know the phase, or the number of diodes, which is 3, and I know the alpha right here for this. Okay, so here I can say that conduction angle, okay, I can say that conduction angle is 120 and alpha is 30. Okay, so if I say that, okay, this is 120 right here compared to 30, so what will be my, okay, 30 equals how many pulses we have? 120 divided by, okay, 120 divided by 30 is how much? No, we know that conduction angle here for the 3-phase half wave is 120 here and 120 here, and same thing, this is 120, and we know that the alpha is 30, so those are fixed, so this will be our reference. So we know that this is 120, and we know that alpha equals 30. Okay, so if I divide 120 divided by 30, I will get 4. Means the 4 will be my reference. I took this from something fixed that I know. Okay, I know that this is fixed. So now I have those values. Okay, so how to find this? Let's say this one is unknown. Now I get the 4, guys, from something that I know, which is the 3-phase. I know that the conduction angle is 120, and I know that the alpha is 30, so I get this. So I can do the following. Since I know this, I know that also 120 divided by 4 equals 30. And I know that this is the conduction angle, and this is the conduction angle, which is gamma, and this is the alpha. Okay? So now, this is for 3-phase, single phase, for 3-phase, half wave. Okay? Now, with this reference, I can find anything. Okay, let me see. I will erase this, and I will leave the rest, but I will work right here. Okay, I know that 120 divided by 4 equals 30 degrees. So this is my conduction angle, and this is my alpha. Let's say that this is unknown. Unknown for a different phase. This one here is for 3-phase half wave. Okay? Let's say that the case is for 3-phase full wave. What will change? What will be different now? I will have the same. I will have 4 right here, because this is fixed now, and this one is unknown. And what will be my conduction angle now? 60 for the diode, right? So 60 divided by, how I know the 60? Again, how I know the 60? I can say 360 divided by 6. I get 60. Here, 360 divided by 3. I get 120. Okay? So now I can know the alpha right here. The alpha is how much? The alpha is 15. because 60 divided by 4 is 15. Let me do it for 4 diodes. For 4 diodes, for 3-phase, actually it's multi-phase now, multi-phase, 4 diodes. So I will come here, I will say 360 divided by 4 equals what? 90, right? So it will be 90 divided by 4, because we really make this one difference from something that we know. And 90 divided by 4 is 45 half, and then half the 45 is 22.5. So 22.5. So that's my alpha. I will start from there. Means, if we look at this for the 6 diodes, if you want the exact, I will not ask you to make a shift, but I want you to know this. The exact drawing now, that you need to make a shift 15 degrees. So your alpha is 15. This one here, my drawing is 30. So to have the exact drawing, this is my 15. This is my 15 here. This is my 15. So I will make a shift. I will make a shift now, guys. I will make a shift here. I will make a shift. 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 This is my new output. This is with alpha equals 15 degrees. My alpha. Okay? This is the exact alpha. Okay? So if I want to draw the 4-phase, okay, I will erase this. If I want to draw the 4, the 5, or the 5 is the same. If I take the 5, I want to take something that it's easy to make the division. So 5, it will be 360 divided by 5, it will be how much? I have here, okay, let's take the 5. Let's take the 5, guys. I will erase also this one right here, okay? I assume you guys okay with this. Okay. So let's say that we have multi-phase now. Multi-phase with 5 diodes. Okay? With 5 diodes. So here, let's see. Now you need to know where's your how much is your alpha, okay? And as I told you, since we have this calculation right here, so we say that 360 divided by 5 equals 72, right? Okay? So 72 right here divided by 4, 72 divided by 4, because we said 4 will be fixed, so 72, sorry. Divided by 4, so I will say 72 divided by 4. This will give me my alpha, which is I think 18, that's 36, yes, 18, okay? And I will come to the calculation. So now when it comes here, just let's see where's, this is my 30, this is my 60, this is my 90 right here, this is my 120, 150, 180, and 210, 240, 270, 300, 330, and this is 360. Okay. Use the blue. So let's see here. I will start from 18. I will start from 18. So 18. This is 15. And this is approximately 18, so here. This is my alpha. Of course it will be raised. This is my alpha right here. So alpha 1 equals 18. Then, how much is my conduction angle? My conduction angle is 72. So you add. So from 18 and 72, 90. Okay? So 90 here. So my peak will be right here. That's one pulse. So this one here is 18, and this is alpha 1. Okay? And this one here is beta 1, which is 90. Also, it's alpha 2, which is 90. Now, what's beta 2? So you add to the 90, 72. So it will be 162. 162. 162 is here approximately. Okay, that's my zero. So then I'll draw. Okay, so that's here. That's beta 3 equals 162, and at the same time this is alpha 3. Beta 2, sorry, this is beta 2. And this is alpha 3, 162. Then you add 72 to that to find beta 3. So 72 plus 162, that's 234. 234 is right here, approximately. Okay. Okay, 234. So you come here. Beta 3 is 234. So you add 72 to this value, which is 162, and this is alpha 4, 234. Next one, you're gonna add 72 also. So 72 to 234, it will be 306. So 306 is right here. This is 300, so next to it. So this is 306. Okay. This is 306. So 306 here. This is my beta 4, 306. And this is my alpha 5, 306. Okay. Next one, add 72 to 72 plus 306. That would be beyond 360, and we're looking only for one cycle. This is my limit right here. I don't want to go beyond. So I go 306 plus 72. That's 378. So subtract 378 minus 60. That's 18, which is this. So this one here is beta 5, 18. And I'm done. Here. See here, guys. That's what you will have. And that's what you will have. So I have 1, 2, 3, 4, 5. That's my output, guys, for Multiphase with 5 diodes. Okay? And those are the alphas, alpha 1. Make sure you know how to calculate this. So if I give you 7 diodes, 4 diodes, 10 diodes, make sure you know how to, you can follow this in page 25 and in page 26. And those are the equations. The equations here, Q represents the number of diodes. Q represents the number of diodes, and this one here, long equations, looking for V out RMS. So you're gonna love this equation. If I give you this equation, I will give it to you. I don't want you to memorize this, but the rest you need to memorize, okay? And here the ripple frequency is Q times the ripple frequency, okay? I think we're done with half wave. Not with half wave. We're done with uncontrolled. We might have we might do some examples before the midterm. Okay. So okay. Thank you.